Ladies and gentlemen, my name is Björn Bartram and I'm pleased to present you the poster of Tim Wilke and me, Nanomaterials in Cancer Therapy, a model experiment for chemistry education. For this presentation, we start with an overview of the whole poster, and after that I present you the contents panel by panel in the intended reading order. So on this slide, you already saw the headline of the poster, normally without the pictures, they are here for presentation purposes. Below the normally headline, you find the introduction into the poster and to the topic. Below that, on the left side, you find the theoretic background, presenting you the main information you need to know. Below that, you find the synthesis, we are on the bottom left of the poster now, you find the synthesis of the ferrofluid and the superparamagnetic nanoparticles for the model experiment. And one way, there are more. And then right next to it, on the bottom center, you find the model experiment and our results with it. On the right center, you find our results applying it in the school lab and our first, and in some outlook, what we are going to do next with the model experiment. Below that, on the bottom right corner, you find our references for the poster. So you now should have an overview about the whole poster. And as I presented to you before, we now want to start with an in-depth view panel by panel. So for that, I start with an introduction. Medical research is a point of interest for many students. Due to COVID-19, it's probably pushed and therefore be more relevant for many students. Nanotechnology presents a relevant approach for many therapies and medicines, and not just for COVID-19, but more likely for cancer, for Alzheimer's disease, for multi-resistant germs. There are many diseases in which nanotechnology could take a relevant approach. Local hyperthermia cancer treatment is one way to go. Local hyperthermia treatment is a special case of hyperthermia treatment. Hyperthermia treatment is when you affect the whole body with heat to damage cancer cells in it. Local hyperthermia treatment is a special variant where you just affect a part of the body with heat and therefore damaging the tumor cells in it. With nanoparticles, it's possible to inject those nanoparticles right into the tumor and then expose them to an alternating magnetic field, therefore through induction heating up the particles and the tumor cells and locally damage or even destroy them. These fields, you may ask, are produced through induction coils running with an alternating current. This mechanic of using metal in an alternating magnetic field is already applied at many homes in form of induction hobs, which you can buy online for like 30 euros. So is it possible to just use your own ferrofluid you bought online or you synthesized yourself on those plates? And if you compare the magnetic behavior of common ferromagnetic materials and superparamagnetic nanoparticles, the heating processes are likely the same in many aspects. But there are differences, and the main I want to show you. Superparamagnetic nanoparticles consist of many nanoparticles representing their own magnetic domain. If now an external magnetic field that is strong enough is applied to them, there are two possibilities they can align their spin to them, to the field. On the left side, you see that the spin inside the particle can just rotate. On the right side, you see the whole particle can rotate and therefore align the spin. So there are two competing mechanisms which both generate heat, but the right one, that the particle just rotate in order to align it, isn't possible while induction cooking with your ferromagnetic pan. The pan won't spin on the field. So there are additional mechanics to produce heat for superparamagnetic nanoparticles, and therefore the other are nearly identical. The induction hob can induce heat through superparamagnetic nanoparticles. So to investigate this mechanics, we need superparamagnetic nanoparticles. You have two ways to go. On the one hand, you can buy them online. Many stores already sell them, and they aren't that expensive anymore in small batches. Or you do make them yourself. And as a chemist, I find it's the more exciting way to do so. So you have 4 steps to synthesize an aqueous ferrofluid. The first step is you solve iron salts in water and add a diluted ammonium solution slowly over time. After that, you get a solid which you want to wash which you want to wash. You want to remove the interfering products from the reaction before. After that, you want to stabilize the nanoparticles so you gain a ferrofluid which is easier to handle and would be easier to inject. After that, you check for spikes because we need a mechanism to test for wherever we have nanoparticles or we have just ferromagnetic magnetite. In pictures, you see on the poster, and I want to show you the way to go here in too. So I'll just show you the big pictures, the pictures in a big scale. You see on the top left, on the picture 1, you see a yellowish solution, which are the iron salts already dissolved in water, and the addition of ammonia. And you can already see on the picture that there are black spots in it, which are the reacting super paramagnetic nanoparticles in the making. So after the complete addition of the ammonia, you get a whole black solution. If you now add a neodymium magnet below the beaker in which your reaction took place, you can see all the particles floating to the bottom of the beaker and be fixated by the magnet. Now you can pour off the liquid on top of it and add new water and therefore wash all the ammonia salts and therefore neutralize the pH value. On the bottom left, on the third picture, you see we already have a viscose, like fluid-like paste, which we gain if we add the stabilizer. Because after washing, you are likely to get a black wet powder, which could remain, could look like iron needles, just a little bit more smaller. So to stabilize them in this, I call it mud at this point. To stabilize them, we use tetrabutylammonium hydroxide, an organic base, which is possible to sterically and electrostatically stabilize the nanoparticles so they won't get stuck with each other so you can get a ferrofluid. In the fourth picture, you see if we hold the magnet below it, not at it, just below it, the magnetic field should generate spikes in the ferrofluid. If you don't have spikes, either you didn't add the right amount of tetrabutylammonium hydroxide, or you don't have nanoparticles. With this ray, we always generated nanoparticles. We mostly had problems in stabilizing them. The ferrofluid cannot be synthesized with not super paramagnetic nanoparticles. You need them, so it is. You can't use ferromagnetics for ferrofluids. For the model experiment now, we place 2 vessels on top of an induction hob. One is filled with water and the ferrofluid, and the other one is just filled with water. Because the induction hob heats itself up due to the process of generating the alternating field, which it negatively affects the measurement. So we want to measure this effect too and compare it to the intended induction heat. So on the left side, we have the ferrofluid with water that should be heated up more than the references, and the difference is that the value generated through the induction. For the temperature measurement, we used the LabPi measurement system of a colleague of mine, Manuel Wehner. You can see his poster as well. I can just recommend it to you. In the sketch, you see how it is planned, and in the lab, it looked like this. As you can barely see on the screen, you can see the value, the power of the induction hob is 3,500 watt. And after 15 minutes, we get the following values. And as you clearly can see, the temperature for ferrofluid in water has risen 2 degrees, about 2 degrees more than for the reference. So we can measure a difference through the induction in the ferrofluid. Results in Outlook. Now we have tested this in school lab with students, and it's already applied, so they can do it again. For STEM teacher education, it is planned but not fully implemented because the synthesis is implemented, but the model experiment not yet because the induction hops had delivery problems, as many things due to the rising pandemic right now. After COVID-19, we hope to implement it into the teachers' training so more schools can be used this model experiment to get the students an interesting view into medical research. As you see on the poster, as you can see here in the presentation, are our references. At this point, I just can say thank you very much for your attention. If you got any questions for the poster, for this topic, reach out to us. I present you here our email addresses so you can just write us an email. Otherwise, you can reach out in the networking area to us. We are very happy if we can answer your questions. In this case, have a good day and goodbye.